Welcome to Section 6.5, Linear Inequalities, Part 2. For a warm-up, let's review graphing equations and solving equations for y. First, we want to graph y equals 3x minus 4. Then I would like you to solve the equation 3x plus 3y equals 6 for y. Remember, when we're graphing, in this case we have slope-intercept form. Our slope is 3, our y-intercept's negative 4. So to graph this, we're going to put a dot on the negative 4. Our slope is 3, so up 3 and over 1 to put the next dot, and then you connect your points. In the second one, where we were solving for y, we're going to subtract the 3x from both sides. 3y equals 6 minus 3x. Please remember, you cannot combine letters with letters and numbers. So this has to stay 6 minus 3x or negative 3x plus 6. Divide everything by 3 to get y equals 2 minus x. You could also have negative x plus 2. You will need both of these skills in order to do the lesson for today. Today we're going to be graphing linear inequalities. So your first step is to get y all by itself. Remember, when you're working with inequalities, if you multiply or divide by a negative number, you have to reverse the inequality symbol. Step 2 is to graph as if you had an equation, with the following exceptions. If you have just greater than or just less than, you are going to graph using a dotted line. And if you have less than or equal to or greater than or equal to, then they're going to get a solid line. And the last thing is since we're not graphing an equation, we're graphing an inequality, we have to do shading. If you have greater than or equal to, you shade above the line. And if you have less than or equal to, you shade below the line. Let's look at an example. For example, we want to graph y is less than or equal to 1/2 x plus 1. So first of all, we have the symbol less than or equal to means less than or equal to. In this case, it's going to be a solid line because it is underlined. So now we're going to go ahead and graph the boundary line, just like as if we had y equals 1/2 x plus 1. We're going to put our dot on 1. We go up 1 and over 2 to get to our next dot. We connect our points with a solid line. Now for the shading, it's less than, so we shade underneath our line. Let's try another one. We have y is less than 3/2 x plus 3. Again, you're going to graph this as if it was y equals 3/2 x plus 3. So you're going to put a dot on positive 3. From there, you go up 3 and over 2 to your next dot, and you're going to connect these with a dotted line. From there, you're going to shade below the line because this is less than. Let's try another one. We have y is less than negative 2x plus 2. Again, you're going to graph as if you have y equals negative 2x plus 2. We put a dot on 2. Our slope's negative, so it's down 2 and over 1. Connect the points using a dotted line, and this time it should be below the line again, so we need to reverse this around. Our shading should be below our line, because it's less than. Y is greater than negative 4/5 x. We put a dot on 0 because it is our y-intercept. We go down 4 and over 5 to our next dot and connect them with a dotted line. We shade above our line because it's greater than. One more. Go ahead and graph y is greater than or equal to a negative x plus 1, and we'll see how you do. First, we're going to graph just like we had an equation, y equals negative x plus 1. We put a dot on positive 1, down 1 and to the right 1 for our slope, connect using a solid line because it's underlined, and this time we're going to shade above because it is greater than. Homework assignment is on page 393, numbers 14 to 21.